In this video, we're going to explore why the common algorithm for multiplying whole numbers works. Now, if you think about the standard algorithm, we first line up by place value, and then we start using the individual digits starting at the bottom from the right, and we multiply to each number above it. And whenever we have something that carries greater than 9, we carry the tens digit, and we bring down the ones digit, and we move left to right. And then as we move to the next one, we multiply and then add anything that's been carried. And we have to then remember also about the zeros, that as we shift to the next digit in our bottom numbers, we have to continue to remember how many zeros to add. For example, if we have 485 times 73, I start by taking the 3 and multiplying it by every term up top. 3 times 5 is 15, carry the 1. 3 times 8 is 24, plus 1 is 25, and I carry the 2. 3 times 4 is 12, plus 2 is 14. Now I'm going to move to the 7. Now I have to remember I shifted over 1, so I put 1 0 down. Then 7 times 5 is 35, carry the 3. 8 times 7 is 56, plus 3 is 59, carry the 5. And then 7 times 4 plus 5 gives me 33. Now I add up my two products, and I'd end up with 35,405. Now, why does this work? And we're going to look at two different ways as to why this works. First one we call the partial products multiplication algorithm. And what this does is it looks at each of those individual multiplications as their own steps, and then you add all the products. You just have to pay attention to place value. So what we're going to do is we're going to start with our 3. And we're going to multiply it by each place value. So we start with 3 times 5. That gives us 15. Now when we multiply 3 times 8, that's not 3 times 8. That's 3 times 80 because that's in the tens place. And this is why it's so important we learn our place value and help our students understand place value. And then we do the same thing with 3 by 4. It's not 4, that's 400. And that also helps explain where the zeros start coming when we multiply our next values, because this is not 7, that's 70. 70 times 5, 350. 70 times 80, 5,600. 70 times 400, 28,000. Now I'm going to add all of my individual products, and I'd still end up with 35,405. Now, a second way I could look at this is using the distributive property, where I'm going to take each number and break it based on the place values and make it a sum. So, same numbers here, but I'm going to break them as sums based on place value. So I end up with a quantity of 400 plus 80 plus 5 times the quantity of 70 plus 3. And if you remember the fact we can do the double distributive property here, I'm just going to distribute my 70 plus 3 to each of the individual terms in the first quantity. Then I get 400 times the quantity 70 plus 3 plus 80 times the quantity 70 plus 3 plus 5 times the quantity 70 plus 3. And now I just do my second distribution. And if I look at this and I look back at the partial sums multiplication algorithm, I'll see that I end up with the exact same values: 28,000, 5,600, 1,200, 240, 350, and 15. All those are showing up in that partial sums, and this is why. So when I simplify, again, I would end up with 35,405.